Alright, we're going to talk about properties of logarithmic functions. We're starting the second half of Conceptual Unit 4. Alright, so we have a logarithmic function, f of x equals log base b of x, with b greater than 1. Your domain would be 0 to infinity, because unless you shift this right or left, it goes from 0 to infinity. The range is all real numbers. This goes forever down and forever up. It's continuous. It's increasing. It's neither even nor odd. It's not bounded. There's no extrema. There's no horizontal asymptote. There's a vertical asymptote at x equals 0. And as x approaches infinity, the function approaches infinity. Alright, so we have a product rule which says if you have log base b of something times something else, you can split it into two log base b's, and you split the multiplication into addition. The quotient rule says if you're taking the log of a quotient, you can take the log of the top minus the log of the bottom. And then the power rule says if you have log base b of r to the c, you can drop it like it's hot, hot, hot. That exponent will drop down in front and be a multiplier instead of an exponent. Alright, so it says, assuming x and y are positive, use properties of logarithms to write the expression as a sum or difference of logarithms or multiples of logarithms. Alright, this is a product. So they're taking the natural log of 8 times x. Well, according to the product rule, I can say that that would be the ln of 8 plus the ln of x. Okay, this says take log base 10 of 3 divided by x. That's my quotient rule, which says I can do log base 10 of 3 minus log base 10 of x, but I don't have to write the base 10. Okay, and the bottom one is my power rule that says when you log something to an exponent, you can drop the exponent down in front, and it can go from an exponent to being a multiplier. So this would be 5 times log base 2 of y. Alright, so let's do some more things here now. First thing I see here is two things. We've got multiplication and we've got exponents. You're going to undo these things kind of in asymptotic order. So I'm going to undo that multiplication first, which is going to give me log of x cubed plus log of y squared, because you can split multiplication into addition. Okay, then you don't want to leave exponents there. So I'm going to drop them like it's hot. So the 3 is going to turn into a multiplier for the first log. 2 is going to be a multiplier for the second one, and this would be in simplest form would be 3 times log x plus 2 times log y. Done. Okay? You got two things going on here. You've got division and you've got exponents. Again, we're going to undo the division first, which we do with subtraction. So it's ln the top minus ln the bottom. And then I can drop my powers, drop it like it's hot, drop it like it's hot. So that would give me 2 ln x minus 3 ln y. Okay, here we've got some crazy stuff going on. We've got a radical, and that's the first thing we want to get rid of. So this would be log of x to the 1/4 over y to the 1/4. Because this I could split into the 4th root of x. Dyslexic much, Tamsin? 4th root of x over 4th root of y. And then to get out of the radical, it's exponent over root. So now I'm going to undo the division with subtraction. So that would be log the top minus log the bottom. And then I'm going to drop it like it's hot. Drop it like it's hot. And I have 1/4 times log x minus 1/4 times log y. Okie doke. Alright, so you try this one. Come back when you're ready. And hopefully you got 2. This is multiplication, so you have log of the first thing plus log of the second thing being multiplied. Okay, try this one. Hit pause, come back when you're ready. And hopefully you got 1. All right, first of all, I'm going to get out of the radicals. So that's going to be log base 2 of 17 x to the 1/2 over y. Now, you've got a couple things going on here. You've got multiplication on top and an exponent and divide. So the first thing I'm going to do is I'm going to undo the multiplication and division. So I'm going to have log base 2 of 17 plus log base 2 of x to the 1/2 minus log base 2 of y. So I undid the multiplication with addition and I undid the division with subtraction. Now the only thing is I don't want to leave that exponent up in the air, so drop it like it's hot, and I have log base 2 of 17 plus 1/2 log base 2 of x minus log base 2 of y. Done. Alright, you try this one. Hit pause, come back when you're ready, and hopefully you got 4. Alright, so we've got multiplication and exponents on top, and we've got division. So I'm going to undo the multiplication, log base 3 of the first factor plus log base 3 of the second factor minus log base 3 of the divisor. Okay, and then the only thing else I can do is drop them like it's hot, drop the exponent, that's going to give me 4 times log base 3 of x plus 6 times log base 3 of y minus log base 3 of 4. Okie dokie. Alright, so now we're going to go backwards. Now they have them split out into logarithms, and they want us to put them back together as a single log. Well, so now we're just going backwards. So you undo addition by multiplying these, by keeping one log and multiplying those together. So I'm going to keep log base 10, they don't write it, of xy. Done. Okay, here they're doing subtraction, which means 1 ln of the first divided by the second. This has to go back up in the air, because if it's a multiplier, it was an exponent. So this would be log base 10 of x to the 1/3. So I took 2 logs and wrote them as 1. 2 ln's, wrote them as 1. 1 log, but I got rid of the multiplier. Alright, so if we do this, we've got a couple of things. Again, now we're going to basically, when we put them back together, your PEMDAS order. So raise them like it's cold. Get it? Drop it like it's hot. So now go back up like it's cold. So this would become ln x squared plus ln y cubed. And then I can undo addition by keeping 1 ln and multiplying the first factor times the second factor. Okay, here again we've got to raise it like it's cold. So this is going to be log xy to the 4th minus log yz cubed. Okay, so now if you, I don't really know how they want you to write this, but when you power a power, that's going to be log x to the 4th, y to the 4th, minus log y cubed, z cubed. In other words, both of these get cubed, both of those get to the 4th. So now, to undo subtraction, I'm going to use division. So I keep 1 log, and I divide the first by the second. And then I guess the only other thing we could do is 3 of these would cancel out 3 of those. So I would have log of x to the 4th over z cubed y. Alright. Go. Hit pause. Come back when you're ready. And hopefully you got 2. Alright, so the first thing I'm going to do is go back up in the air. Back up in the air. So I'd have log base a of x to the 2/5 plus log base a of y to the 1/7. Okay, so then I'm going to undo the addition by keeping 1 log base a, and I'm going to multiply that by that. So I'd have x to the 2/5 times y to the 1/7. Okay, go. Hit pause, come back when you're ready. And you should get 2. Alright, first thing I'm going to go up like it's hot, So that's going to give me ln x to the 7th, y to the 7th, minus ln y to the 5th, z to the 5th. So now when I undo my subtraction, I'm going to have 1 ln x to the 7th, y to the 7th, over y to the 5th, z to the 5th. And yeah, then they canceled or reduced the y's. 5 copies on bottom gets rid of 5 of the 7 on top, which leaves 2. So I have ln x to the 7th, y squared over z to the 5th. Alright, try this one. Hit pause. Come back when you're ready. And you should have 4. So back up, back up, back up. I'm going to have log base a of x to the 1/2 plus log base a of y to the 4th minus log base a of x squared. And then you have 3 logs that I want to put together as 1, so log base a. To do this addition, I'm going to take this times this, so that's going to be x to the 1/2 times y to the 4th. And this is going to turn into division of this, so x squared. Now, the only thing is the x's on top and bottom. X to the 1/2 divided by x squared is x to the 1/2 minus 2. If I get a common denominator, this would be 4 over 2, which would be x to the negative 3 over 2, which in a denominator would have to go to the bottom. So I have log base a of y to the 4th over x to the 3/2. Okay? Alright, so briefly explain the product rule. Well, if you have log base a of x times y, that's log base a of x plus log base a of y. Quotient rule, if you have log base a of x divided by y, that's log base a of x minus log base a of y. The power rule says if I have log base a, or 2 times log base a of whatever x, then this would be log base a of x squared. Okay? Alright, change of base formula. Your calculator only understands log base 10 of whatever. If you're going to use a calculator, unless it's base 10, your calculator is going to do you absolutely no good. So lots of times we really need it to be base 10 so that we can analyze these things. Well, we have a change of base formula which works out very nicely. Let's say that I have log base 3 of 10, and I want to figure out what it is, and I want to use a calculator. Well, again, I've got to change my base to base, let's not make that 10, it's going to get confusing. Log base 3 of 7. I need to change this to base 10, and all you do is you say log base b of x is log base a. You can make it whatever you want. Obviously, we're going to use base 10 because then the calculator works, of x, which is that guy, and then you divide it by log base 10 of your base. Remember, your base is always on the bottom. And then you can type it in the calculator, and you would just type log 7 divided by log 3. And you would get 1.7712437449. That's a change of base. Alright, so it says use the change of base formula in your calculator to evaluate the logarithm. Well, this would be log base 10 of 7 over log 2. Log 175 over log 8. Log 12 over log 0.5. And then you just type it in the calculator. Log 7 divided by log 2. And I get 2.80735 blah blah blah. Log 175 divided by log 8, and I get 2.484. Log 12 divided by log 0.5, and I get negative 3.4 or 3.584. 585, if I read. Okay, that's change of base. So try this one, hit pause, come back when you're ready, and hopefully you got 4. I would do log 295.8 over log square root of 3. And remember, now we're base 10. So if I type log 295.8 divided by log square root of 3, enter, I get 10.3579463. 4 decimal places, 1, 2, 3, 4. The 4 isn't going to do anything, so 3579. Alright. Try this one. Hit pause, come back when you're ready. And hopefully you got 2. Again, you would type log 0.54 divided by log 2. Alright, evaluate or write the expression using only natural logarithms. All you're doing is the exact same. You're still doing change of base. You're just going from a log, a common log, to a natural log. But it's the same thing, because still all you're doing is changing base. So this would turn into ln of x over ln of 3. This would turn into ln of a plus b over ln of 2. We don't have to solve it, simplify it. It just said write it using natural logs. Alright, common logs. Common logs means change it to base 10. I don't know why I put ln's there. So this would be log x over log 2. This would be log x plus y over log 1/2. Oops. Alright, so go, hit pause, come back when you're ready. And hopefully you got 3. Again, common logs, you would go to base 10. So log of x plus y on top over log of the base on bottom. Alright, so the change of base formula says that if I have log base a of b, that I can change it to log base anything I want. Let's just call it x of b, and this would be log base x of a. It's just normally we use base 10 so that we can use a calculator. Alright, so we are at homework, which means we are done. So, happy homeworking, and I'll see you next time.